3, 2, 4, 5, 6, 7, 8, 9. Okay, so these will be 3 different graphs. Okay, so in the first case, if we have no real constraints on the particular edges, then we consider this to be an undirected graph. Okay. In my second graph, perhaps we might have an arrow notation which indicates you can travel in this direction, but only this direction. Okay. So in this case, you can go to 4 to 5, but you can't go from 5 to 4. Okay. And we would call this directed. Okay, in terms of its edges. And finally, we can add on one more thing to this. If that's a really bad arrowhead. We imagine a third graph, but this time we imagine that this has a cost, this has a cost, and this has a cost. Okay, so if we add some type of cost to this, and again, the unit here can be time, it could be distance, it could be whatever. Okay, and what's interesting here now, if we sort of ask the question, well, what's the cheapest path to get to from, if we start at 7 and we want to get to 9, well, we have 2 options. There's 2 valid paths here. Okay, we can go directly 7 to 9, but that carries a cost of 30. If we go indirectly from 7 to 8, that costs 15, plus 8 to 9 with a cost of 10, that costs 25. So we actually might want to be able to explore the graph and find the shorter path. Okay, but this is an example of an edge weighted graph. Okay, and in this particular case, it's also directed as well. We can tag that on. Okay, so these let us model different situations.